do things with continuous integration and Jenkins, which used to be called Hudson, but Oracle bought them, and there's a big war, not a big war, but a little war. And then, yeah, now it's called Jenkins. Same software, same guy, different project name. Yeah. So, what is PHPUnit? PHPUnit is a test suite framework. It's produced by a guy named Sebastian Bergman, who's a very interesting character, if you've ever talked to him. He's a nice guy. He's a character, though. It's pretty much the standard in PHP. It's used by Zen Framework, Symfony, Easy Components, which is maintained by Derek Reathens, who's one of the other PHP developers, and numerous other PHP projects all use PHPUnit for their test suite. And there's a few reasons for that. One is it's really great. It implements all of the features that are available in other languages like JUnit. Well, not all of the features, but many of the features that are available in suites like JUnit or NUnit, a lot of those features are also available in PHPUnit. And it's PHP 5 compatible, which makes it quite nice. It supports all of the features in PHP 5, and it has a lot of other features that other test frameworks don't really offer. And we'll get into that. So some of the improvements that it has over simple tests. If you've done any unit testing in the past with CakePHP, all the tests were written with a library called SimpleTest. One of the primary reasons for this was that SimpleTest was PHP 4 compatible. And so we've had, Cake has been around for a while, SimpleTest has been around for a while, so both of them worked. But since we're moving to a PHP 5.2-ish, 5.2 plus environment, it made a lot of sense to also switch to a much better test framework, just to get better tools. Can everyone hear me at the back? Am I talking too quietly? Yeah. So some of the things you get that are much better. You get way better command line tools. SimpleTest does not have command line tools. You have to build them. We had to build them, it sucked. PHPUnit is all command line, so we had to build a web runner. So you still have access to a web runner just as you did before, but there's also way better command line tools. Better coverage reports. PHPUnit can generate coverage reports for an entire application or an entire test suite group. In the past, we had to write, we wrote our own test coverage report generator, and it only ran for one class at a time or one file at a time. With PHPUnit, you can generate coverage reports for an entire suite and get a much more comprehensive view of what your test code is actually covering. You get a better selection of assertions. PHPUnit comes with a much broader set of assertions and a much more rich language and way to create your own assertions. Better mock objects. Mock objects in SimpleTest work, but they're not as comparable to the objects in to the mock objects in PHPUnit. And we'll get a little bit into mock objects and just some of the things that you can do. It's far more extensible. You can create your own assertions for mock objects. You can create your own types of tests, and that's all very useful. Better toolchain support. SimpleTest does not integrate with other things very well because it doesn't have a command line runner. So with PHPUnit, you get access to really good command line tools. You can generate Clover reports, which is a data format that JUnit exports. So a lot of tools can read that data format and then be able to give you more useful information. And so like when you're in Jenkins, you can see test coverage report. You can see the number of tests climb. You can see coverage reports climb. You can generate all of that and have it all in a single server. There's pretty much no downside to PHPUnit. Nothing bad. You didn't lose any, nothing got lost. Everything just got better. It's faster, it's more feature rich, everything is better. I can't think of a single thing that got worse. So the assertions. One other thing before I go into the assertions is that some of the APIs are a little bit different between SimpleTest and PHPUnit, and inside Cake we've made wrappers that provide compatibility, so you don't even have to upgrade your tests. If you haven't done anything crazy, as far as assertions wise, you don't have to upgrade any of your assertions. They all work. Mock objects you will have to update, but the assertions you don't. The main reason we did that is because we're selfish, and we didn't want to have to update the, I think, 15,000 assertions that are in Cake. So it was more self-serving than, it's self-serving and helps everyone else. Because upgrading 16,000 assertions is a pain in the butt. Yeah, so you don't have to do that. So assertions are much stricter in PHPUnit. SimpleTest, pretty much all of the assertions are loose equality. In PHPUnit, all of the assertions are strict equality, except for a few of them. There's more of them. There's more varying types of assertions that give you a lot more useful pieces. You get better reporting on failure. Instead of failures just saying it failed, you get like diff reports, which we'll see in a bit. The interface is much more consistent. In simple tests, some of the interfaces were a little bit reversed of each other, and you had to remember which ones were which. With PHPUnit, everything's exactly the same because it's built by Germans, and they're very thorough and very precise. And it's easy to extend. PHPUnit doesn't support the type of fixtures that Cake uses, so we were able to really easily add that in, and it's really easy to add in other features, like if you want to use your own fixtures. You don't like the ones in Cake, you don't like dbUnit, you want to build your own. It's not hard to do that. So assertions are stricter. So you can see all of these tests would pass in simple test. All of these tests fail in PHPUnit. So when you're upgrading your application, you may be doing things like assert that save returns true. Well, save actually returns an array, which is truthy, but it's not true. So assert false on an array will fail. It'll say an array is not a Boolean false. This is bullshit. Same with null. In the past, assert null would take false, would take empty string, it would take 0, it would take all kinds of things that aren't null. PHPUnit wants null, and only null will pass. Assert true is very similar. 1 doesn't work, the string doesn't work, only the Boolean true will work. So yeah, strings don't work. All of this will pass in simple tests, so you might have been getting some silent passes, even though they were technically they could be types of fails if you're doing identity checking inside your application. Yeah, there's more applications. So in the past, when you wanted to make sure a string was inside another string, you had to do assert true, stir pause, string, and other string is identity equal to false. And now you don't have to do that. You can do assert contains. Assert empty asserts that an object is empty. It'll work on strings. It'll work on arrays. It works on numbers. Yeah. You can assert that files exist. You can assert that a file path will exist. You can assert that a file's content is equal to another string. So if you're making tests that are generating files, it's really quite straightforward to figure out if the file contains the thing that you think it does, because you just write the assertion. There's assertions for objects, so you can assert that an object is a specific class. There's also assertions that I didn't write. There's one called assert internal type, or assert type of, and it will allow you to assert that variables are an array or an integer or a string or null or false or true. Better failures. So the failures in PHPUnit actually output diffs. So it puts out the lines that it thought it was going to get and the lines it did get. So it's usually generally much more straightforward to figure out what went wrong, because you can see that it was expecting this is some text on multiple lines, but we got this is some words on a second line. So those are the differences that it found, and it wants you to fix them. Whereas in the past with simple tests, it would just say it failed. I can't give you any more help. You're on your own. And then you'd have to output, like echo the result, echo the expected, try and figure out what changed. So this is actually considered much nicer. It's consistent. Every test takes the expectation, the result, and a message that is output when it fails. Every test. I haven't found one that breaks this rule. Yeah, it's nice because you don't have to think, unlike PHP where you have to remember, is it needle haystack? Is it haystack needle? You can just go, it's always expectation, result, message. Assert equals also takes a couple extra parameters. So if you're asserting the equality of floats, you can actually put a tolerance as the fourth parameter, which says I'm willing to accept 0.00001 as the difference. And if the difference is less than the decimal value you give, it will ignore the failure, because floats are fun like that. You can make 1 not equal 1, which is fantastic. It's pretty easy to make your own assertions. Just by wrapping the native assertions, you can make a base test case in your application that contains a bunch of assertions you use for things that you commonly have to do. And it's really easy to just wrap one of the base asserts with a custom assert. And you can actually, there are assertions built into PHPUnit that you'll get two assertions for calling a method once, because PHPUnit has built its assertions out of its base assertions. Annotations. Normally annotations are not supported by PHP. It's something that libraries add in. PHPUnit has added in a few assertions in order to make a few things a little bit easier. And it's similar to Doctrine, but in a different format. If anyone has questions at any time, you can just ask. I like taking questions as I go, because I'll burn through my slides really quick and I want to ask a question. So the annotations are basically doc comments, and that do stuff. They allow you to make assertions, they allow you to generate tests, they allow you to, those are the main things. And they allow you to deal with output buffers. So you can create declarative tests. You can say, I have this set of data, I want to run n tests, and I want to not have to write a for loop in my code, and remember to call setup and teardown before each for loop, and those kinds of things. So testing exceptions. Cake actually throws exceptions now, so if you do things that it doesn't like, it will throw exceptions at you. You can also you are encouraged to throw exceptions from your own application. PHPUnit makes it really simple to test assertions, test exceptions. So instead of having to do a try catch, so you do try the function that you want to test that could raise an exception, and then fail. I'll just show you, it'd be easier then. So instead of having to do like try, message, something bad, do it. Oh no. So instead of having to write all of that each time you wanted to test an exception, you can just write this. So you just call the thing that's going to cause the exception, and you can actually assert the class name of the exception, the message that's going to be output inside the exception, as well as the exception code. So you can make 3 assertions for free in a comment instead of having to write all 3 assertions. And what PHPUnit does is when it reads a function, a test function, it parses the doc comment, looks for any annotations, and then runs those as assertions under the hood.
How would you do that? Writing the method instead of using annotations?
Yep.
Because I find annotations, you can oversee them.
Yep. So you'd have to do, this would do the expected exception.
Oh, so that would be...
So then you'd have to do this assert equals 25. Well, I have these backwards. Get code. And then you have to do this.
And do you think that, do you find that people use more the explicit assertion or annotations?
I like the annotations. I don't know what people use. Internally in Cake we use the annotations pretty much exclusively because this is a lot of boilerplate code to write. I like things to happen for me for free. So you'd have to write basically that. Yeah, you'd have to write that to get what you got in fewer lines of code, but some comments. Some of the gotchas with doing dot comments is if you leave off the second star, it will not work. This is just the way that PHP's reflection works. It requires that you have /**. If you put /**, you will spend countless minutes wondering why things don't work. And it's the extra star. Yeah, the extra star is critical for PHP's reflection system to be able to find the comments. So always make sure you have 2 stars. Very important. Generators. So generators are very useful in that they allow you to generate a set of tests. So say you're building something that parses text or compares numbers or does some sort of routine process where a set of inputs equals a set of outputs, which is hopefully most of your tests. But let's say that that is a static set of data that you can easily type out, and then you want to be able to run all of the tests at once. So you could write test adding to, test adding for, and so on, and write separate methods for each one. Or you could declaratively state out, these are the tests I'm going to run from here to here. Each one of these is a test. These are the parameters for the test method. So I'm going to put, I have 2 tests that I'm going to run, and I make a static function that says data generator, and then I just put this data provider with the name of the method that's going to be called as the data generator. then each of these arguments gets placed down as it's a one-to-one thing. So then you can just make one assertion, and all of the tests will run as one. And the nice thing about a data provider over doing a for loop is that before and after each of these functions, the setup and teardown methods will be called. So if your setup and teardown is cleaning up all of the state of your test, creating and cleaning up all of the state of your test, then the data provider works perfectly. Whereas with a for loop, you could have contamination between the tests inside the for loop. Does that make sense?
Mark, have you ever used that? I mean, this totally makes sense, like with like addition, but like thinking about like some sort of complex method, right? Because maybe it's not simply adding numbers. Like, can you assert the result of that operation as well?
Yeah, of course. You can basically use these as parameters to the test. Yeah. You don't have to have one of them be the expected. You could do some operations based on the parameters and then assert that's a known outcome. Generally, it's nice to have the outcome inside the test because then it can be in line with the data. But yeah, if you want to see an example, I can pull one up. I don't know if it'll work very well. Oh, shut up, Vim. I have this weird thing where Vim likes to save every file on blur. Sometimes it doesn't work so well. Okay. Data provider. So this is this test uses a data provider, and you can see that it does a little bit more complicated assertions. So it makes an exception renderer, sets the response to, makes a mock, makes an assertion, makes a mock expectation, starts an output buffer, renders an exception renderer, like renders an exception page, and then grabs the output, and then does some assertions, does a number of assertions. So the generators for this looks like this. So I have probably 25, 30 tests here, and all of them basically start off with an exception that I want to test, the assertions, the patterns I'm looking for inside the test. So I'm going to look for those two patterns inside the page, and I'm expecting to get this kind of error code. So here you can see that I've got the exception, some patterns, and a code. And basically, the exception renderer, I take the arguments, do a little bit extra complicated logic, and then, not complicated, it's fairly straightforward. Some extra logic, and then I can make some assertions, any number of assertions. So you can use generators for that type of thing as well. Like if you're going to be processing a bunch of text, and you want to make sure that the results match, it's good for that as well. So those are data generators. Output buffering. We do a lot of work with HTML. That often means you're outputting something. PHPUnit comes with a built-in way that saves you having to write ob-start at the beginning of all your methods. The other thing it does is it also cleans and empties the buffer at the end of the test. So if you screw up the test somewhere along the way, it doesn't just eat all of the output. So you can just turn output buffering enabled. You can do this at a function or a class level. And so you can have output buffering on for one test method or all the test methods in a class. And then it will automatically close the output buffer as soon as the test is finished if you didn't do it. Actually, you don't have to close it. It'll automatically close itself. So you can get the contents as you go through, and then it will close the buffer for you. One key difference with PHPUnit versus simple test is when simple test runs a test, it hits the first fail, it keeps going, it hits the second fail, and then you get this huge cascade of fails. So it could just be that the first test failed, which caused all of the other tests to fail. In PHPUnit, the first test that fails raises an exception. So you never get to the lower down assertions because something's already gone wrong, so why would you continue? Whereas simple test will just keep on trucking and like, must finish. PHPUnit just gives up and says, oh, something's broken, I'll just try again later.
You can tell how many tests fail after like a code change? You just know one by one?
You would know that each test method has a failure in it. So it's both good and bad. It's good because if it motivates you to write smaller test methods and have more test methods, more small test methods. But it's bad in that if you have several hundred assertions in one test method, you might get halfway down, hit a fail. You don't know that the rest of it's failed. You just know that that one test has failed. Hopefully you're disciplined enough to say, oh, I've got a broken test, I should probably fix that. And then you'll rerun the test, another one will break. You just keep going through and fixing them all. But it's nice in that you don't get like 6,000 assertions failed. You just get maybe like 10.
Did you guys break the core into pieces?
Yeah, we did. We broke up some of them. We didn't break up all of them. It'll probably come. Fixtures. They work exactly the same. Nothing changed. Yeah. Yeah, it is what it is. You can also use DBUnit if you don't like the fixtures that Cake uses. DBUnit allows you to use CSV data sources, XML data sources, so you can use all kinds of fun data formats to make your test data. So if you don't like the way that Cake does its fixtures, now you have 2 more options, and you can make your own. So you can do whatever you want. Yeah, some people don't like the Cake fixtures, some people really like them. Some people really like DBUnit, some people really hate it. It gives you a few more options as far as fixtures go. Mock objects. So they're better built. The simple test ones, I hate them. I've been using them far too long, and there's just a bunch of little tiny things that drive me crazy. The mock objects in PHPUnit I've been using for about 2 years, and they don't drive me crazy yet, which is good. They're more expressive and more powerful. They work with exceptions. You can have mocks that throw exceptions. You couldn't do that in simple test. You could return an exception, which isn't really the same as throwing it. And they're extensible. You can make your own pattern matchers. You can make your own, what do they call them? I can't remember. There's matchers and something else. But you can make your own and hook them into PHPUnit. So doing things, common things. Most oftentimes you use mock objects for making stubs, like stubbing out an expensive resource, stubbing out a web service. You can make it, we'll start off with stubs. So let's say you're making a test that uses authorize.net, and you don't actually want to process payments during your test suite because it'll cost you millions of dollars over the course of your project. So what you can do is use a mock. So getMock actually creates a mock object, and what it does is it looks for this class name and then subclasses it. So you can't use mocks if you have any final classes. So don't use final classes, and you won't have any problems. You can also get mocks for abstract classes and interfaces. So PHPUnit can generate a stub based on an interface or based on an abstract class, which is quite useful if you want to test the concrete methods in the abstract class. So basically what we're doing here is that should be an array, so don't do that. We're just going to stub out the process method, and the methods are supposed to be an array, but I made a typo. So then basically you start saying you start building an expectation. So this mock expects that once the method process will be called with an order, and it will return the string order successful. And that's pretty much the expectation. Then you call a method, set the gateway, pass in the mock, and then you call order process. If this expectation isn't met, if this method is called twice, if it's called 0 times, if it's not called once with this order, if it's called once with null or with some other crazy value, the test will explode. And it will return this, yeah. If at any time an exception is raised, it will also fail. One thing to note is if you're using mock objects, do not put try catch exception. Always type your exceptions a little bit more specific than exception, because if you catch the base exception class and swallow it, you'll actually catch all of the exceptions that come out of the mock objects, and your test will not break and will not pass. You'll be stuck in some sort of weird test limbo where your code is broken, but you don't know because you're just eating the exceptions. So either don't write code that eats exception, the base class exception, or don't swallow exceptions. Catch them, log them, and rethrow. That's a really important thing. If you have catch exception, that's burned me many, many times. I got lazy and I'm like, catch everything. Who cares? Yeah. It looks like you had a question. No? Okay. So you can also use mocks to simulate things breaking. So have you ever built something and you're like, this will never break? It only breaks when the database server's down. That'll never happen. That's impossible to test. How can you possibly test when authorize.net is down? We have to wait for authorize.net to go down before we can break it. So you can actually use mock objects to break shit. See, what you can do is simulate a failure. So if you know at one point if authorize.net is going to be down, this method will throw an exception, but you can't get there because you don't want to, when you connect to authorize.net, you open that socket, it's always up. So if it isn't up, you can throw an exception, but you never get there because it's always up until it goes down, and then you're... So what you can do is use mock objects to fake out what happens when authorize.net is down, or what happens when PayPal's down, what happens if your database server goes down, what does your application do? What does this class do when the database is gone? I don't know, let's find out. So you can make a mock, just as before, and then you can do expectations with at. And what at does is it checks the index of the method. So if the method is called the second time, with process at this order, it'll throw an exception. And you just basically put an exception class, an exception instance right in there, and then this will throw it. The at is actually a little bit different than how Simpletest handles at. Simpletest handles at on a per method basis. So each method has its own method counter. In PHPUnit, the method counter is shared across every mocked method in the class. At first, that really pissed me off. I'm like, why didn't you guys build it the way Simpletest built it? But then I thought about it and worked with it a little bit more, and it actually has some interesting uses. With Simpletest mock, it's impossible to ensure the order of methods called on a mock object. So you can't say this method was called first, this method was called second, this method was called third. All you can say is that each one got called once. You don't know the order. And if the order of the methods matters, it's almost impossible to test. With PHPUnit, you could mock all three methods, assert that one gets called at 1, assert that the second method gets called at 2, assert the third method gets called at 3. And if the index of the methods changes, the test will fail. So in that way, it's much better, because it's a lot more picky, but you're testing things. You want to be picky. You can also use mocks to make sure that other objects are interacting with, to make sure that the object under test is interacting with other objects in the proper manner. I don't know if I explained that well. So let's just make sure that our controller is modifying the response object correctly. So we can get a mock of the response. We can say we expect the header to be called once with a location, and we want to redirect to posts. So we can set the response property on the controller, call our method, and if we don't ever call header, then this method has failed. So it's a good way to ensure that the code you've written properly interacts with the code that you have from a library or other objects you have in your application. So you can ensure that interactions are happening properly, and also that they're happening in the correct order and the correct number of times. So using mock objects requires some different strategies. One, you have to be able to get the mock inside your object. So there's a couple ways you can do that. One is through the constructor, so when you construct an object, you put its dependencies in. Another is you have a setter method, so you say set this thing, and you can overwrite the method that's inside another object. You can also expose them as public properties, like we do with controller response. You just smack that property with a new object. That's an alternative. But you will need some way of getting the mocks into your code. Those three ways are generally the simplest. You can probably come up with some really complicated dependency injection system based on XML, and then you open up the container object and switch the objects inside, but these work quite well. I've never run into a situation where I needed a container that parsed XML. Code coverage. So, code coverage is useful for figuring out how much of your code gets run by your tests. So let's say you've written 100 tests, but you haven't covered, you want to know how much of my code is actually covered, how much of my code actually runs during my tests, and has some remote possibility of properly working. Coverage does not indicate that the code is correct. Coverage indicates that the code is run. You can make test cases that create 100% coverage, but don't actually test anything. But you can just call the methods, don't assert anything. You'll get 100% coverage, but your tests are still garbage. So code coverage is useful, but it's not the only number you should look at to see how good you are at unit testing. You want to do a composite of the number of tests, the number of assertions, And if you can go into your code and delete 10 lines and nothing breaks, you probably don't need that code, or you should write more tests. The code coverage in PHPUnit requires you to have Xdebug installed. Xdebug can be installed through Pickle on Linux and BSD machines, or you can get it, there's an SO file on somewhere for Windows. You can generate code coverage reports in several formats. There's Clover, which works really well with integrated systems like Jenkins. You can generate a comprehensive HTML report, and you can make single HTML reports. And they all have different uses. So generating a Clover report, you can do from the command line. So inside your app, you can just call console cake, because there's now a cake console inside your application that bootstraps your app correctly. So you can call test suite. You want to enable the Clover coverage and put it into a file called clover.xml, and you want to run all of your tests and generate a Clover file that's going to be read by Jenkins or some other tool that can read Clover files. There's also these ones. These are the complete HTML reports. So what it is, it's a full, I'll actually just generate one in a minute. It's a full report for your entire application. It takes a while to generate. Depending on the size of your application, it can take a while. But it's very thorough and gives you a lot of useful information. And it requires a lot of memory. So make sure you up the number of memory, the amount of memory allocated to PHP before trying to run these, because they suck up memory like a beast. So to generate those, you can just basically do, I have the development version just sitting here. CakePHP core. So the test running, now it's generating code coverage report. It takes a while. That's what I mean. All right. So what it generates is this report that tells you how much of your code it thinks it's covered. It's very pessimistic, and you'll see why in a second. So we only ran the core directory tests. So you have to, it will actually generate code coverage for every file that ran during that request. So if you have pair libraries, it'll generate all of the code coverage report on those. And there's ways to exclude your files from PHPUnit's code coverage, but we didn't do that right now. All right. So you can see that we have 0 of 0 classes covered, or only 75% here. And it's very pessimistic. So you can have 71% of the lines covered, but PHPUnit counts that as a 0. Because not all of the lines in a method are covered, so it says 0. And until all of the methods in a class are covered, the class counts as a 0, even though it's actually 75% of line coverage and function coverage. So PHPUnit takes a very pessimistic approach on your code, because it's built by an angry German. That's not really nice to say about him. He's a really nice guy. So you can also get into detailed reports, where you can see that this line was covered once, and this line was covered 0 times. Some of the methods were covered 6 times. Yeah, there's supposed to be a pop-up that shows you which methods covered it, but it doesn't work. So yeah, you can see how many test methods in the suite that you ran get to that line. So those are the full coverage reports. These are great to look at. They're really big. They're fun. So those are the full coverage reports. Oh, we did that. You can also generate an individual report, which is the report that Cake offers from the web runner. It shows an individual class, so if you run a single class's code report, you can generate that on the fly from the web runner. It's much faster because it only does, it only does one class, so it's much faster. I'm sorry. So you can run these from the web test runner. So if we were to run, let's say, anyone want to see one specific? Let's run this one. No, that one's boring. Let's run this one. So we run the tests. You can click Analyze Code Coverage just as you did before. This is basically the same code coverage report as we had before, but there's a new option to toggle all the files. So you can see all the other files that got partially run while this test was running. And you can also look at the code coverage for all of those. So we can see that this class had 97%, which is pretty good. Not too shabby. And you can hover over a line and find out which test methods ran through this line, which is kind of nice. So if there's a test you think should be reaching a line, but it isn't, yeah, it looks like I never test the XML. Oops. So that's the other way you can get code coverage out of Cake.
There was a line that wasn't boring, it was just a closing bracket. It wasn't making sense.
Yeah, I don't know. Parsing, Xdebug is a little bit flaky sometimes when it gives you which lines are dead and which ones are uncovered. Sometimes it makes mistakes. Yeah, there's another one. I don't know. Can't win them all, I guess. Yeah, so we could look at this one. You can see that this test didn't actually cover that, so maybe we need to go in and fix that. So those are the HTML reports. So the runners, there's two runners. We've seen both of them throughout the other demos. There's the web runner, which runs it from the web, from a browser, and there's a command line runner, which we use to generate the full coverage report. The biggest difference is what you do to get the test to run. That's the main difference. There are some gotchas with the command line runner. If you don't have PHP configured to have sessions enabled in command line or APC enabled in command line, some things work a little differently. So you just have to check your PHP configuration and make sure that both APC, if you were using APC, make sure that APC is on, otherwise it'll just not work. And also make sure that your sessions are enabled in command line. There's a flag you can use to suppress that if you can't change that config. There's a std class, which makes all of the output from PHPUnit go into std instead of stodout. Or I don't know if those are the right pronunciations. That's what I call them. Into std instead of stodout. And that won't get you colors, but the tests pass, which is nice. So if you have session tests or anything that's using the session or sending headers, you might see warnings that the tests are failing because headers have already been sent. And then you might want to just run those tests again with standard error, and they'll probably pass. And that's just the difference between PHP in a web environment versus PHP on a command line environment. So either change your config or change your other thing. Yeah, so the main difference is how you use them. We did that. Continuous integration. Has anyone here used Jenkins or any type of continuous integration server before? Yay! So continuous integration is fantastic. It runs basically the idea is you have a server that watches your repository. Whenever you push code to your repository, this other server checks out the code, runs the tests, and then can send you a bunch of annoying emails or Jabber messages or IRC messages to tell you that you broke something. It's really great because it ensures that the tests always get run after every push or every commit. And it's great for if you have a team that's disconnected or people sometimes forget to run all the tests. It's great to have something watching you and making sure that you do it. And it's just a great way, like, if you can automate it, why not? Like, have a robot take care of a part of your job. Yeah. So, I've installed Jenkins on my computer. Don't use the Mac installer for Jenkins. Download the WAR file itself. If you download the Mac OS installer, it installs it as a system service, and that turns on as soon as you boot your computer, which is really annoying because it uses like a non-trivial amount of RAM to run. So it's good to have a separate box or put it on the same box that your hosting is on, or like a server that's not under use. It's not so good on a development box. So starting Jenkins is pretty straightforward. You just do java jar or Jenkins var. It's a mouthful. Jenkins comes in with a built-in web server. You don't have to deal with Tomcat or any other, what do they call those, servlet containers. It'll boot out just out of the war file. So it's running. Poop is everywhere. It runs on port 8080 by default. Or better. Yay. So I've made a build for CakePHP. It's a very simple build. So basically the idea in Jenkins is that each build is a job, and you can have multiple jobs. You can have as many jobs as you want, as many jobs as your server can handle. You can create jobs with the new job. You can look at the history of the builds, and each project gets a line on the dashboard. So you can see that the last one was successful. There's been 2 of the last builds have failed. That's the name. This is how long ago the last pass was, as well as the build number that passed. Last passed, as well as the last build that failed, and how long the test took to run. I'm only running a fraction of the tests, so it only takes like 12 seconds. And you can schedule a build. The way that Jenkins works is if a Jenkins server gets busy, there's 2 executors, which are on this machine. You can do more advanced configuration options where you have slave machines that are executors for the master Jenkins server, but that's a pretty complicated setup. So I would just start off with just one server with 2 executors. If you have a dual core machine, it can run 2 jobs at the same time. So a job is basically some source code, some shell scripts, and that's it. All of that configuration lives inside of Jenkins. To configure a project, you can configure a project. So when you build a new project, you basically get the same screen. And you can connect Jenkins to basically any kind of source control. It comes built in with CVS, Subversion, and that's it. But you can easily, there's plugins for Mercurial, there's plugins for Git, there's plugins for Perforce, there's plugins for Bazaar, Darks, there's plugins for basically every repo that exists known to humankind. You put the name of for the Git ones, you just put the name of the Git URL, what branch you want to build when it builds, and there are triggers. So you can either have it pull the source control, so just peg the source control, or you can use more complicated things like webhooks. So if you're hosting your project on GitHub, you can have GitHub fire a webhook to Jenkins, and then Jenkins will run the build, which is pretty fancy. So you can execute shell commands. Jenkins runs inside a shell. So I'm going to put some config files, because I don't want the config files to be in my source control, and I want Jenkins to use a specific by itself database. So I just basically generate a config file for the database config, just inside a shell script, pipe it into a file, and then that will get re-initialized on each build. So every time you build the project, it generates that file and then runs the tests. So you can see that I generate a database config file, and then I run the script that's going to run my tests. And the way Jenkins works is the last script that ran, if the last script that ran returns a non-zero status, the build fails. If the last script that ran returns a 0 status, the build succeeds. You can see that in my terminal as well. I have a little happy face that tells me the status of my last command. So if I run the tests, it stays happy. If I go in and break a test, so I've just added an assert true, assert false, assert true, false, which is most certainly going to fail. It should fail. And then when you run the test runner, I get a sad face because it failed. And you also get a stack trace of where the test failed, so you have a pretty good idea of where to look. So because the script will exit with a fail status, then Jenkins can actually break a build. So we're going to run a build, and you can actually do a whole bunch of stuff. You can execute shells, you can execute Windows batch files, you can execute execute any type of Maven. And then there's also a whole host of plugins that you can hook into to run other tools after Jenkins. You can SSH into servers and update your staging server on a successful build. So if you have like a staging server, you push your code, Jenkins runs the tests. If the tests pass, it SSHs into the staging server and then updates them. If you have huge, like you're very confident in your code working, you can SSH into production and update that. I would strongly, strongly advise against that, but you can do it. And then you can also do post-build actions. So you can archive the artifacts. The artifacts are generally outputs of the test. So if you have a project that compiles objects or compiles an application, you can store that application. You can have it trigger builds on other projects. So if you have projects that are linked together and you want to have this project succeed and then run this project, you can do that with Jenkins as well. You can have it publish JUnit tests, which are the JUnit log files, which is another thing that PHPUnit can generate that simple tests can't. Is a JUnit file which tells you the number of tests you have, the number of tests in each file, and it makes a little graph on Jenkins. You can publish Java docs, and you can send emails. So if a build fails, you can email everyone on the team. You can have it log into Jabber and send you messages. You can have it spam you on IRC. There's a huge host of Jenkins plugins that you can use. So to run a build, you just click the build button. And you can see the build started, and we can actually watch the console output if we get there fast enough. There we go. Oh, network's down. Build failed. Oh no. Guess I should connect to the Wi-Fi. Yay. So you can look in the console output, see that the build failed. That's kind of annoying. Let's go back. Oh, I didn't commit that. This is pulling from the actual repo. So I can schedule another build. There it goes. Look at the console output. Yay, it finished. So that's how you can do what you can do with Jenkins. It's a pretty great system, pretty easy to set up.
So when it fails, it gives you the whole output of the...
Yep. Yeah, we can go back through the jobs, back through the builds this job has had. So you can see that there's a red fail. So we can click on that job, failed to determine, it doesn't know why it failed. Sometimes it knows, sometimes it doesn't. And you can see here that it's basically could not fetch from any repository. Yeah, total tank.
Yeah, but that is a failure within Jenkins. I'm saying a failure within your test case.
Yep.
You get the actual stack trace and everything.
Yep, it'll output whatever would be output into a terminal. So with PHPUnit, you'll get this type of output, and that'll all be in the Jenkins output, inside the Jenkins console log. Yep.
I mean, it looks pretty simple, but is there a good introductory resource you recommend to review?
Yep. Yeah, the Jenkins website is actually really fantastic. The Jenkins community is top-notch. They have a really great IRC. They have a great mailing list. Jenkins, it's jenkinsci.org. Which gives you all the downloads, as well as access to the wiki, which has a lot of information on it, how to do different builds for different types of projects. Gives you a few tutorials on how to get Jenkins set up, how to get Jenkins to run your project. Yeah, that kind of stuff. There's also tons of plugins for Jenkins. So if you love plugins and modifying and configuring things, you can go into Jenkins and manage plugins. And those are the ones I have installed, but these are the ones that are available. So it's huge. Avatars. There's one for Chuck Norris. You can have like,
what?
Yeah, Chuck Norris will like have pithy comments on your builds. Yeah.
Something like Dotson.
Yeah. There's what else is there? There's IRC. There's Jabber. Yeah, Notify.io. It can message you on Skype. It can message you on Twitter.
New ways of getting more back.
Yeah. Yeah, so there are tons of build reports. Yeah, there's all these different ways of doing build reports. So you can do things, you can do pretty much anything. And Jenkins is Java, so if you know Java, you can build your own plugins as well. Build tools, yeah, Gradle, Groovle, yeah, tons of stuff. So it's a really, really fantastic program. Yeah, that's pretty much my talk. Does anyone have any questions? I don't think I went. Did I go really fast?
No, I think you were
Right on
time.
time?
Early.
Oh.
I'm sorry.
Yep.
What's the performance of PHPUnit like compared to simple Jest?
I haven't never measured it, but it's considerably faster. I've noticed it being a lot faster. Yeah, I don't have any numbers to back that up. It just feels faster. Yeah, it just feels faster.
Yeah, Mark, what about you mentioned webhooks?
Mm-hmm.
And then scheduling a build like just at set intervals?
Yep.
What's the kind of strategy right now, like for I guess you could set up rather than a webhook, a post commit hook with Git repo to kind of trigger a build?
Yeah.
If it's more than
Yeah, GitHub offers the post commit hooks. The webhooks that GitHub offers are its post commit hooks. So on a post receive, GitHub can fire a webhook with basically what you would get in a post receive if you were running your own Git server. You can also configure Jenkins to just pull the source control. So if you don't have something that's going to give you notifications, you can set it up to just pull the source control. You might have to install a plugin for that. Build periodically. You can put basically a cron tab schedule. So the 6 stars that I doubt anyone can remember offhand. You can also pull the source control. So you can give it another schedule. You can say every 2 minutes, just ping this server, see if there's any changes. And you can do the build when changes are pushed to GitHub. Well, that's from the GitHub plugin. I think there's one for Bitbucket, and there's probably one for Codeplex. Not Codeplex, the other thing that I can't remember the name of. Yeah. Yep. Yep, I'm planning on it. It'll probably email me. Yeah, no, that'd be nice. I've never looked at running Jenkins on a public web server, so there is some sort of authentication you can put in front of Jenkins, so people can't just go in and change all the config around. Jenkins works really great, like it's 5-minute setup if you're running it on an internal network. I've never tried to set it up on a public website, so I'll let you guys know how that goes. Yeah. All right. No one else has any questions? I'm done. Yeah. Oh.
CakePHP customization.
No.
Only PHP annotation.
There's no custom annotations in CakePHP, but I'm pretty sure you can add your own annotations in PHPUnit. There's probably a little bit of hoops you have to jump through because that's kind of buried deep down in the bowels of PHPUnit, but you should be able to add more in, I would hope. If not, file bugs against PHPUnit until Sebastian fixes it. He's usually pretty good.
Is there a place that you have the migration PHPUnit documented in terms of what people changed in tests?
Yeah, there is a wiki page for it. It's mostly just the mock objects. Most of the assertions all work exactly the same. You'll probably get a lot of failures on stuff like assert false with an empty array, or assert true on an empty array, that kind of stuff, or assert true on like number 1. There'll probably be a lot of those weird failures. When we first migrated, there was tons of those failures, and it's just a lot of like tedious, like, oh, it's an array, fine. Do assert false bool cast on the thing. And there's some regex scripts for migrating the assertions, but you don't have to do that. They all work. Okay. Thanks.